share. First, okay, you can see my screen.
Yes.
Okay. For okay.
Okay. I think it is mine.
Before analyze the data using Cytoscape, you need to prepare the data and new share. Yeah. This file I will use for today's tutorial. First, because you have many kind of sample. So, for example, today I will use feces sample from NGS data like nomin or scriposan, maybe later akadasan and zabisan also have the feces sample. So first I will show you how to analyze the data and use that data to show the relationship with all the interaction between bacteria and bacteria. And later I will show how to show the relationship between the bacteria in feces and, for example, blood metabolite, or in case of Peterson, maybe he want to know the relationship between milk component and milk microbiota. Okay, so before going to Cytoscape, I will analyze it in JUMP software. You can use this software in the laptop of our lab. Now you can see the Excel file or not? No? Okay, I will show you the Excel file. Okay, you can see the Excel file. Okay, this is the original data when you receive you finish analyze using Chime. You will have this, including the bacteria taxa from phylum to family level. This I choose at family level. You can analyze at genus level as well. And remaining column is sample. So in my case, here I have 30 sample. And so from this data, we usually we will filter at 1% the original data, because I want to see the bigger number. Then I already multiply with 100. It means this is 2.2%. This is 4.6%. Like that. So if the original data is have a smaller number, then I already multiply with 100. So in this case, it is 1 is mean 1%. Then to everybody already know this step, right? How to filter the data. So I will skip this step. I only okay. So we will make the criteria range here, and from that data we already filter and the sample which have at least 1% in the sample. So we have this file, and from this 1% at family level, I will convert into this file, just into this file, just by you place with this function. So you change from the column from the row into the column. So each column here is its material family. Okay, and then we will use this data to show the interaction between bacteria and bacteria. Then I will analyze this sheet of data in the Zoom software. And I will do like this. And okay, share. Okay, first let's open that in Zoom software. Yeah, feces. Sorry, my laptop quite slow and it take time. Maybe because I run many software, maybe I should turn off the Internet Explorer. Okay. This and this I will select this file. Okay. You can see, and this is a bacteria filter at 1% at family level. Then to see the interaction on the correlation between bacteria and bacteria, first we go to analyze, go to multivariate method, and choose a multivariate. And what we need to do now is choose all of the family here, but I will ignore the other because it didn't give much information. Then click OK. Okay, so the data is quite many. Then we don't need to care remaining here. Just this table shows the correlation between bacteria and bacteria, and we need to see it at the spearman, using spearman, because this is the relative abundance, so the data is not normal distribution. So we use the spearman method to analyze this data. Then we have this table. This table shows the interaction between bacteria in this column and this column. And what we need now is to copy this into a new table. And choose right click and choose make into data table. Yeah, you already have the data in this table. Okay, The data here is include the p-value from lowest to highest. I will short. You can see from lowest to highest is nearly 1%. Nearly 1 is mean the correlation. The p-value. This is p-value. And we usually choose the p-value is lower than 0.05. It means the significant difference. So we will delete the relationship that have the p-value higher than 0.05. From this here, I choose and delete this. Right click, choose and delete row. Okay. And remaining is the interaction or the correlation between material and material, and with the p-value is lower than 0.05. And we should save this table into the Excel file, and later we will use in the Cytoscape. Save and go to choose Excel, and this is spearman. Let's say spearman, and this is 1%. Okay. Maybe I need spearman. Now, do you see the Excel file with spearman?
No.
Okay. Spearman. Okay. You see? Okay. This is the file already export into the Excel file. Then this file is we will use for the Cytoscape analysis. Next, what we need to do is let's change the spearman value here. Okay, first let's set another column as the relationship. So this column will show us the correlation between bacteria. This bacteria with this bacteria is positive or negative. If the value is lower than 0, it has the negative correlation. And for example, these two bacteria, they have the positive, they are higher than 0, then it is positive, and it is negative. So we need to label all for all of these correlation. To do it fast, I will sort it. Sort based on the spearman column. Spearman. So one is two. Okay. Then here you can see here is the negative value, and here is the positive. Then I will add this data faster. Yeah, it is negative. Sorry. Okay. And remaining is positive. Then copy, I will paste for all of this. Okay. We will want to see it clearly, and I only keep at 3. Okay, 3 number. Next, so in the Cytoscape, we can show the relationship at the color of the the edge, and if we want to have if we want to show the strong or the strength of the correlation, we should make another column and label. For example, here I want to use the spearman as the strength of the correlation. Then I will use this data, and I want to get the absolute value of the spearman, because I don't want to see because this value is mean the minus here is show the negative correlation, and 0.9 here is show the strength the strength of the correlation. Then I already label the positive or negative in this column. Then I don't need to keep the negative here. And I only keep the absolute value of this. You can see it can become positive like this. Then I will do for all of the value. Yeah. And I copy into another column and only keep the value. Then I will delete this. I only keep the absolute value of the spearman here. Okay. Okay, another step. If you want to show the relative abundance of these bacteria in the cytoscape, you need to make another column and label as abundance. Later I will show you. And then you need to abundance. Then you need to get the relative abundance of these bacteria. And then I will sort into the variable because I want to add the abundance for this bacterium. Then I need to make another is you still see the Excel file, right? And here I will make get the abundance of this material. So to get the representative abundance of this bacteria, I get this abundance, another column, and then get the average value, of all of these sample. Yeah, it is the average value of this bacteria. And okay, I will make another column and only keep the keep only the number, and I will sort it so that I can see easier. Sort based on the family. Here you can see we already have the abundance of this bacteria. Then what we need is to copy this abundance into here. Here you can see Morgibacteriaceae. Then you copy and paste for all of this here. Okay, here is Parabrebotelaceae. be into paraplemotacy. Yeah. Alkaligenacy, minus here. Bacteroidaceae is Bifidobacteriaceae is taken is Clostridiaceae, Eripsea. Yeah, and be careful because if you copy wrong data, then remaining downstream you have the wrong data. You need to be careful. Chronicle test? Why is that chronicle test here? Maybe I shouldn't have this. Okay, but just for demonstration, because chronicle test is already at the phylum level. So maybe I didn't delete that. Okay, but just for example, I will keep it. And okay, then I should delete this wrong data here. Delete this. Delete. Atmospiracy. No. Okay, atmospiracy. Yeah. Atmospiracy. And methanobacteriaceae. Catostatocaceae. Okay. And poly. Proteidaceae. Proteobacteria. This also at phylum level. Looking at RF system. For on. Victoriaceae is going to finish. And Laminococci. Succini. Pleurisy. Delo. Okay, done. Okay, next let's go to, we will use this data for Cytoscape. So I will move to Cytoscape. Share. Okay, you can see the Cytoscape. Okay, let's choose. This software is free software, and you can download and find many information or many guide tutorial on YouTube or also on the website. But for this purpose, our NGS data I will show here. I will choose, for example, here. Let's just open the previous version, what I did, and then I will analyze the data. Next, I will show you the interaction between bacteria and bacteria. and how to see, the cytoscape will just help us to visualize the interaction of these bacteria. These are just my previous data that I will import that the data that we have just prepared. Okay. Spearman here, this file. Okay. Let's choose the sheet that we have the two columns, including the family family 1, family 2 here, Spearman, p-value, and relationship, and abundance. Then what we need to pay attention or take care here is because the bacteria, then we can choose. Did it here? They have the many nodes. Here, for example, source node, uh, target node, interaction, and add attribute, and source node attribute, and target node attribute. And we need for first two columns, we need to choose the source node and target node. Here, because the bacteria, then we choose here source is also okay, or here source is also okay. But in case of, for example, rumen fluid, microbiota, and BFA, then the source should be rumen fluid microbiota, and the target should be BFA, because the BFA cannot affect rumen microbiota. Then the source should be the factor. And that's the relationship here. We choose for the interaction type. And abundant here, remember, because previous we described the abundant based on the first column. Then first column is source node. Then we need to choose this column as the source node attribute. And then click OK. Okay. This is the data I will show. Okay. We did our data, and it's also show the interaction, but it's quite complicated, and we need to make it more beautiful and easier to see. So we can use some layout here. For example, grid layout. It will show like this, or circular layout like this. Usually for this we choose decrease of circle layout like this. And we can change the shape or the color of these nodes. we change the we can change here also. There are many style here. Depend on you. You can choose which is preferred. Like this. Usually I choose this. Okay, and for this we call the node. Is bacteria is a node. And for example, if we want to change the shape of the node here, we can choose for example ellipse. Okay, yeah, already changed. And the height of the node, for example, I choose 50, and the width also 50. And also the size, here we can see the label font size. Is, here is 12, so I will increase into 30. Okay, or maybe a little bit smaller, 27. Okay. And it still look not beautiful. Then previous we already set the color, and we also attribute the negative and positive correlation. Then now we can attribute for that that is interaction. Interaction, describe mapping, and here we can see N is for negative and P for positive, and we can add the color for that for negative here. Negative, usually I choose at green one, and positive I choose red one. Then you can see the color of the edge of the line already changed. And you can stop me and ask anytime you want. Okay. And next we want to change the weight on the thickness of the edge on this line. Base we already prepared that. I should delete this. Here you can click on white here, and then at the column we choose spearman this, and contours continuous mapping. So it's the thickness already changed, and we need to make it smaller. This usually I choose 1, and this I choose 7. Okay, 7 is okay. So we already can show the positive correlation or negative correlation, and also the strength of the correlation already show in the thickness. And next, what we want to do is to show the relative abundance. Which bacteria have a higher relative abundance and which have a lower relative abundance. To do that, we go to the node, because each bacteria is each node. Then we need to go to the node and go to the height here. We should choose at height and white. White here. I should delete Okay, and at height, choose which column? Abundance. And we choose continuous mapping. And yeah, white. We also choose similar, choose abundant and count continuous mapping. I should add the color so that you can see easier which color we want. Okay, this color. You can see the size of the node already changed, but some is still small. Then I will need to increase. I will make it into 30, and here is 80, for example. Then we need to change here also. Similar, you can choose 30 and 80 so that your shape will become circle. 80. Yeah. Okay. It's almost finished. So what we need to do more is to just to move the name of this bacteria family out of the node and choose select, go to select, choose amount drag select and choose node label only. Then you can move out this. Do you have any question until now? You can ask me anytime. Okay. Any question now? Okay, remaining. Okay. This may be wrong. So you can directly delete here. Just click here and press delete on the screen, and then choose again. For here is decrease short circle layout. I will change again. I select not. Here also another wrong. Here choose bacteroid test. We also wrong. From this also wrong. Uh, okay. Oh yeah, proteobacteria. Then we do again. Yeah. Layout and degree shot or not. Select label. Oh, yeah. Okay. Any question? Is okay. Okay, I want to show you a little bit more. Okay, for example, in layout here, in layout, you can zoom. Like this is like you make it smaller or bigger based on this scale. This you cannot use, or you can rotate. You can see you can rotate this, but you can see the label is not changed. It's always straight, and this is easier for you to manage. Okay, but I prefer this. And another thing, in future, if you want to, for example, here you see many interaction, then you want to know, or you only want to keep the interaction that have a strong interaction. 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 No. Spearman. Yeah. This. You can see the interaction here is ranging from 0.368 to 1. Then, if you increase the criteria, like okay, you only keep the material that have the Spearman correlation higher than 0.5, then it's already removed or only keep. For example, here you can see if you choose like this, it didn't choose any. But if you lower the criteria, more node will be selected. Okay, for example, here I will keep at 0.5. Okay, and how to handle with this? You click in here, new network from selection, and choose from select node and select edge. Is changed into another new. The old one is still here, but did they keep the new one? Okay. That is one for the bacteria interaction. If you don't have any question, I will move to another section. Is okay? When I make the abundance column, sorry, I couldn't hear clearly. I couldn't hear clearly. I explain again about the abundance.
Yes.
How to indicate the abundance for the
abundance.
Okay. And go to about Spearman. Okay. Okay, abundance. Here, I use the data. Let me show this. I use the data that I already used for zoom analysis. Only use this data, and this data, you can see it it is the same data that you analyze for the jump shot, for the jump for spearman, and use the same data to get the relative abundance. Yeah, yeah. So that if you want to have the reliable data, because for example here you can see in my case I have this is 0 week and 4 week plus and 4 week minus. Then from each set have a 10 count. So from this 10, I also can get the relative abundance uh, of this, right? I can, for example, I can get the relative abundance for only here, for only this 10 sample. But in this case, I didn't do that. I used the relative abundance for all the sample that I already, yeah, yeah, just average for that. Yeah, and then we sort just to show high which bacteria is higher and which bacteria is lowest in relative abundance. And also in the spearman, you can see we also sort. So just for easier to handle, to add the data here. You can add the relative abundance for this column or also for this column. It doesn't matter. If you add for this column, then when you in the cytoscape, where
We can select this from where
yeah, you can select for column 1 or column 2. It doesn't matter. But for example, if you select for you add the relative abundance for column 2, then when you input the data, yes, experiment, then in the abundance here, you should choose at the, for example, target node. Here, target node attribute. So here, if you choose target node, here should be target node. Okay, target node, and here also target node. If here is short node, here you should choose at the short node attribute. If you don't choose like this, you cannot see this column in where can I see? In height here. You cannot see in here. Like that.
That is target inside. To see the last part. Could you clarify?
Last part about the relative abundance.
No. To see the target.
Okay. Okay, I will choose again for spearman here. Spearman. For here, right? For bacteria, actually the source node and target node is not important. So it's only important. Okay, I will show you directly here because I will show in the edge. Because I choose this line, this kind of line, it cannot show which is source and which is target. But if you choose at the no, not here. Short arrow. Yeah. If you choose like this, You can see which is short and which is target, right? If we choose, okay, by looking at here, you can see this is for this bacteria and this bacteria. This is short and this is target, right? Then for bacteria and bacteria, that is not important, and we also don't know. But as I told you, the BFA and rumen microbiota, we know the rumen affect the BFA. Then in that case, we choose the rumen microbiota as the source and BFA as the target. Just that.
And that selection. There are three selection.
Okay. Experiment. So the short here, target here, or short here, target here, it doesn't matter for bacteria interaction. And another, the three important thing is short, target, and interaction. Yeah, for example, here the relationship is interaction type, positive or negative. So we choose a relationship as the interaction type. And if you don't have this column, you can skip it. You don't need to choose.
And from
Abundant. Yeah, abundant. No, abundant here. For previous, we add the abundance for the first column. Yeah, right. So the first column here is the target. So in the abundance, we should choose target, not attribute. You can see the orange color, and here orange color, right? But if, for example, if you choose here is short notes, okay, target, and here you can see short note is at green. And then here we should choose the short note attribute, green one. Same here and here, same color. Okay. Yeah, that is a fitting for the first section. Any other question for this? Okay, if no, I will move to the next step. Next section is about the interaction between bacteria and like blood metabolite or milk component, or in Azimuth-san case is fermentation products. Okay, I will. Choose what? Yeah. Yeah. So similar with fishes. Here I have the data for milk sample. This already filtered at 1%. And then I turn to a column, also including at 0 week, 4 week plus, and 4 week minus. And this is only the milk microbiota. So similarly, if you want to see the interaction between bacteria and bacteria in the milk, you just analyze this data in JUMP and it will show you the spearman, and you do similar with feces sample. But now if you want to see the interaction between the mule microbiota and some, for example, in with milk component, then we need to add the milk component here. Now I'm finding the milk component data and to add there. Milk component. Okay, I already add the milk component here. Here I have the milk vitamin and also milk component for only only at 4-week plus and 4-week minus, because at the 0 week I didn't have the data. Okay, so next we also will use a jump to analyze the to see the spearman analysis for this sample. First, I will close some. This is a little bit more complicated than previous. Okay, I will import. I will import that table. And to statistic, import. Okay, the data already imported. And first, I want to see the interaction between milk microbiota and milk component. Response should be, I will choose that here. Y. Response and factor is milk microbiota. No. Automatic. I think again. Factors should be you. You mean why I didn't choose you? Because I think yeah, we can include, but I think it's quite I don't know, but maybe it's not. I don't know if how the milk microbiota affect milk yield. But we can try. We can try to see factor. Maybe factor should be this. So how milk component affect milk microbiota. Okay, and okay. This show a lot of data. Okay, but we don't need to see. We don't need to see that. What we need to see is here. Just click in the bivariate fit here in this arrow and choose. density ellipse and choose 0.9% as the p-value is lower than 0.05. Yeah, here it show the bivariate fit here, and we want to see the correlation. We can see by clicking in this triangle and see, we can see here they show the correlation between the bacteria and milk component like this, and show all. You can do by just press control and click on this table. Here you can see this, and you can add into data table, but like this because you didn't choose, you didn't press control, so it only add this table. If you press control and right click and choose make combine, make combine data table, no need to control. Make combine data table, then it will combine all the table together here. Okay. Okay, and close here. Just for you can see here there are many tables. Yield with methanocyanoBacteria, somatic cell count with methanoBacteria C, many. And if you only if you right click and choose make into data table, it only show you this table. But if you choose make into combined data table, it's combined together, all of these tables together. Then we delete this empty column by right click. You can like delete this row manually like this, manually. But you have another way to do faster is right click and choose select matching cell. Then it will automatically select for you. And you go to here, right click and choose delete row. Then you delete all of the empty row. Okay. And what we need in this table is we want to have the name of the milk component and milk bacteria. We did this column and this column similar. Then you can delete. Then usually we will delete this, delete column, and delete this. So this correlation and this p-value is based on the normal distribution. They consider your data as normal distribution. Then if your data is normal distributed, you can use this data. But because here we use the relative bundle, then usually the data is not normally distributed. Then you cannot use the this correlation and this p-value. Then we need to use usually we use spearman. Then we will calculate the spearman and then add into this table. Then I close this. Okay, this step go to analyze, do similar with bacteria interaction. Go to multivariate method and choose multivariate here, and then choose for all the bacteria and also the component you want to analyze, and click OK. Okay. And here, click in this triangle and choose non-parametric correlation and choose spearman. Then you have this table. and right click and choose make into data table. This already in a one table, then you don't need to choose combine. You don't need to choose this, but choose this. Okay, you already have another table which have the spearman and also the p-value here. But what is the problem here? Well, problem is here you can see the interaction, also have the interaction between bacteria and bacteria here, and too many, and here is the milk gills, like milk component and bacteria. And what we need here is only the milk yields, milk component and milk bacteria. Then we will combine these two tables together. Okay. Now what we want to do is to combine these two tables together. This table, I want to add these two columns into this table. And how I can do that? First, I click on the table that I want to add the column. This, in this case here. And then I go to table, go to update. And the table that I want to connect is the table 13, this table. And then choose match column. I want to match X. Let me see. X with the variable match, and Y with by variable match. And then which column I want to import, I want to match is spearman and p-value. Yeah, so in now the spearman and p-value already imported into this table. So you want to ask?
I am not here. The combination of the two.
Okay. I will delete.
Why do we need to combine?
Why I combine these two? You can see. Okay. First, let's delete this because we don't use this column. There. Okay. In this table, we only have the name of the milk component and milk bacteria. Then now I want to add the spearman and p-value for this interaction. Why I don't use this table only? Because this table they they include many interactions here. You can see. So I only want to get the interaction of the milk component and the milk microbiota. So I want to find this column in this table. This column in this table. Maybe you didn't. I need to use the annotate. Annotate. Local. So now I just want to combine the want to find the spearman and p-value in this table and fill in this table. So to do that, go to table, go to date, choose this table, match column, as this, for example, as with by variable. I know it's not correct, but I will choose. And then select and go to choose these two. So if you choose wrong, the data will not appear. Here, what we need to do is just choose again. Go to date, match column, choose the table, and choose add with variable, y with by variable, and select spearman and p. Okay, then if you choose correct, it will update here. Then I don't need this table. I close this. Then you already have the table similar with material and material interaction. And what we need to do is sort this to remove the interaction that have higher than 0.05 and with p-value, and delete. Then this is the table data that you need to use for Cytoscape, and save as Excel file. And this is spearman milk percent. So we already have the table similar with the fecal microbiota, and we should make another column like relationship. Another column is what? Abundance. Yeah. For relationship, we should sort with spearman data, sort and spearman. Then we add, like here is negative. Two is finished here. And here is positive correlation. And abundance. In this case, you also, okay, first, next I will change the spearman here into the absolute value. Okay. Right. And then okay. And copy and paste here and the value, and then I delete this. Okay, and abundant here you can see abundant. You only can add for the milk microbiota. Then and this maybe in my case I don't add like the concentration, because the concentration of this vitamin on this component is different. then I don't add for this column, but I only add the relative abundance for the mu microbiota. In this case, I sort with Y. Okay, and for milk, we also similar. We will like I will place. I will choose again. Here, copy. Here, I use the same data that I analyze, and then okay, the average of this. Oh, apply for all the sample, and then I copy only get this data. This is make this easier to see. Okay. And I sort so that I can see easier. Sort with column A. Yeah. So what we need is now you are seeing this file. One, two, sorry, I will share. I didn't share with you, right? Milk. Okay. Then what we do similar with fishes. I Mogi. Find here Mogi and arrow cockroachy. Bacillus, Bacteroides, Coma monadasi, Corine, Eripsi, Lacto, no, Lacno here. So, no, mitochondria, there is not bacteria, I believe that, and Moraceraceae is also. Mitochondria, I don't know why it's appeared there. Moraceraceae, Pioneer, Pseudomonas, Staphylococcus. Okay. Okay, we are ready for the Cytoscape. Let's go to Cytoscape. Okay. Okay, let's import the table that we already prepared in Spearman. I'm sorry, Spearman. So in this case, what should be the short? I think the male component is the short, and this is the target. How male component affect male microbiota, and then relationship. Yeah. What about abundant? You can see here, abundant here we are making for the material in the target node. Then here we choose target node attribute. Okay, and layout. Here there are many layout. You can try like layout like this. It's very complicated and organic layout. This is also better, but it's also difficult to see. Usually, I will use this function like group attribute with I didn't make. Okay, I will show you another way. For example, here if we sort at degree short circle layout, I will make it bigger. 30 and shape is ellipse and white, but hey, okay, this will be later. Here, if you didn't make another column to separate between the male component and male microbiota, when it's short, you only have no option. You don't have no option. You have no option, but so it means now if you want to select, you have to select manually. You need to find it and you separate it like this. You separate and to make it more beautiful. But if you make another column like spearman, okay, if you make another like type of sample, I will choose my okay, milk. I'm making this column for this, so all of this is milk. But in case, for example, I have a feces sample, so I want to see feces with, for example, milk component. Then here is the feces, right? Then I will make here is feces. But here I only have milk. Then this is okay. I will move back to the Cytoscape. Then if I will import the table, that table, import, it is on target, the relationship, this is target, and type is also target. This attribute is for milk microbiota, and milk microbiota is target. Okay, and then choose okay. Okay, for example, now I will do again for the preview software group attribute. For the group attribute, I can have the type here. Then it will automatically separate the milk component and milk microbiota. I want to make this. Okay. And now I want to know which bacteria have the most interaction. Then I choose only the bacteria, and I go to layout and choose decrease short circle layout and choose select node only. Then you can see this bacteria have the most interaction, followed by this, and the bacteria in this is have the least interaction. And similarly, I want to sort for the milk component, which component have the most interaction. So we can see milk beta carotene and milk vitamin A have lots of interaction. And for example, you want to make this, if you want to make this bigger, you can manually move, but it will not beautiful. Now you can use this, you can zoom it bigger, and you can see it become bigger. Like that. Okay, I want to make it smaller. Make it small. Like this, or okay, next I will make the attribute, the add first. Label at the here is interaction. Right? Scratch and choose as what? Okay, new test value. No, I choose wrong. Label color. Should be label color. Interaction. Display. And this is negative, and this is positive. And why it didn't change?
You press OK.
Let me see. And I choose wrong. Choose wrong. Here should be color here. This to label to change the color of the edge to this color. This first column here. I choose wrong. Yeah, delete. You should delete the previous one. Or if you don't delete, sometimes it will misunderstand. because the previous data will mix together with this. Then you need to delete the previous option, negative and positive. Okay, and also for white, even here you can see, but this is for previous data. Then you need to delete and then choose again white, and this is spearmint. And so spearmint this continuous. Oh, and we need to make it smaller at 1 and at 7. Okay, okay, it's okay. For the size, you also can do similar. Size is choose height. I prefer the round shape, circle shape, and I keep here is continuous. Right here, here is the previous data, then I delete and choose again, and then continuous. It's very small, then we need to adjust 30 and 80. And here, 80. Okay. And if you want to change the shape, you can change the shape manually one by one, or you also can delete this. For example, I want to change by type, and describe. Here I only have one type, it's milk. Then I choose a rectangle, and it becomes rectangle, and remaining protein and milk component is this. And I also want to change the color. Milk color here. I delete previous, and this also by type. Milk. I choose that which color? Pink. Okay, this is okay. Okay, then we can change. Or if you don't want, you can change manually. Just if manually, choose name, and this graph, and you can choose, and you can change this bacteria with this color, this bacteria with this color. You can see this change. With this color, you can change for each bacteria. And also the milk component, you also can change manually. Color. I choose type. Okay. And then just move out this, or usually with this type of displaying data, I see it's not easy to see. Then I prefer to show it at the straight line like this. So I can see the interaction clearer.
But there is no way you can remove non-significant interaction.
What do you mean?
There is interaction. Oh, okay.
Because here already show the degree. I already shot this have the most interaction and this have the less interaction. Then I just keep with that order. This one. Oh. Okay. And we can make it become straight using in the layout tool. You can here like this function, you can make it straight. Mixed function, this make it distribute equally. And similar I can do for this. This. I want to make this bigger. And bigger. Okay, I want to make it a little bit smaller. Okay, and the size of this, maybe I want to become 40. And then what we need to do next is just move out this. Do you have any question? Yeah. And similar, if you want to see filter, photo filter, you can filter to keep only keep the some sample that have a high p-value. No, the lowest p-value and the highest correlation. You can choose like column filter. For example, first I want to choose that the p-value. Where is p-value? Probability. This you can see here. So I only, for example, I want to keep 0.01 only. Then I will make select column. Oh, so only these two in the blood in the milk component. This style. This milk beta carotene and milk vitamin A. And okay, add another criteria. For example, you want to keep spearmint here. All of them already higher than 0.908. For example, if you want to 0.6, for example, 0.6, only keep the interaction that higher than 0.6. Then this. Okay. So remaining S5 is short effect. Choose this and okay. Okay. So you see, if we make the criteria stricter, then we only keep the strongest interaction and with a high p-value. And if you already satisfied with your result, you can save it, export into your image. And usually I choose, here there are many file type, but usually I choose JPEG file, image file, and choose it is the mail and component into, okay. And choose try to keep at high this zoom quality. Yeah, zoom and okay quality. So it's already saved in your folder. Just that. So you have any questions? I already finished.
I have a book of that.
Huh?
I have a book of that.
Okay.
Okay. Thank
Hey.
you.
Hey.
Very much.
Thank you.
Very, very.
Thank you. Hello.
2 hours.
Yeah. Hey, that has been my pleasure.
But the Zoom was not